be discussing the k nearest neighbor algorithm. This is also one of the classification algorithm which is used to classify the given new sample based on the training data set. So here we have a number of distance formulas mathematically. In this session we will be following equality and distance formula in order to find the k nearest neighbor. Basically the core idea here is if we want to take any decision, then we have n number of friends together with us in our gang. In that case, it's purely our decision to decide from how many friends we have to take the input. Of course, all the friends will help you to take the decision and tell you their perspective, but we are going to restrict it with the number k. That's why it is called as k nearest neighbor. You are going to first ask with very close circle or very close friends alone first, and then based on the voting we are going to decide. For instance, if you are asking with the 3 friends and one friend is saying you to take the decision yes, and other 2 friends are saying you no. So in this case the majority voting is no, right? So you will be taking the decision no based on the majority voting. So if I have 10 friends, you are going to first choose 3 friends who are very close to you, and from those 3 friends you are going to take the majority voting, and that will be freezed as the result for your decision. This is how this k nearest neighbor will also work. Based on the equality and distance, you are going to first find the distance. This distance helps you to identify which 3 friends you are going to choose. Similarly, the k nearest neighbor will tell you which the closest point, the k number of closest point can be identified, and from those k points, once you have identified those k points, from that you are going to take the majority voting. Whichever is higher, that results will be fixed as the classification result for the new incoming sample, right? In this we have a rule called k. For example, if you are going to find the k values, if for here we have the training data and we have 2 different features, study hours and sleep hours, and the class label is a result. Totally we have 1, 2, 3, 5 samples here in the training data set. Now the new data point which needs to classify is student with the study hours is equal to 4 hours and sleep hours is equal to 6. Now we have to say whether the student will get pass mark or fail mark. What is the result of the student? That should be classified, right? For this first step is we have to find the k nearest neighbor. Alright, so for those k nearest neighbor, first you have to find the value of k, then only we can identify how many members are very close. If k equals 2, you have to identify 2 nearest points. If the k value is 5, you have to find the 5 nearest points. So first task is you have to find what is the value of k. Now to find the value of k, we have a formula which should be applied on it. Before applying it, you should know that k value should not be very low and k value should not be very high. It should be medium, and always choose k value as an odd value, not an even value, because if it is an even value, while you take the majority voting, then it will result in tie, right? If I am taking 6 as a k value, then it is an even number, right? So 3 can vote yes, 3 can vote no. In this case, it will be a tie. We will not be able to decide what is the outcome of the given sample. So for this, always have k value as odd. If you are getting k value as even after calculation, you have to either make it as -1 or +1. It's up to you. You can take it. So the formula for finding k is root of n. N is nothing but the number of data points or number of samples which is given here. So according to our given training data set, we have 1, 2, 3, 4, 5 samples, 5 data points. So let us take root of 5. So this will give you the value of 2.2. So by approximating it, we will take the value of 3 because 2 is even. So I'm going to take it as 3. So the K value is 3, which is odd number. In this, the majority voting will not get into tie value. Alright, now we'll get into the problem. So here, now you have to find 3 nearest data points in order to classify the given label. And the sample is given to you, right? What is the sample? We have study equals 4 hours and sleep equals 6 hours. Now the K value is 3. You have to find the 3 nearest data points among the given 5 samples. Which are the samples that are very closest to the given sample, right? That will be found by the distance formula. Now we have to find the distances. I'm going to find distances from, what is the given sample? It is 4 and 6. So the data point is 4, 6, right? Just let us take the first sample. First sample is nothing but it is 2, 8 gives fail, right? What is the data sample? 2, 8 fail. That's what I have taken here. 2, 8 is fail. Now I am going to apply the formula in it. What is the formula of the equilibrium distance? We have x2 minus x1 the whole square plus y2 minus y1 the whole square. This is the formula which should be applied. So I am going to take the value here now. So which is x1 x2 value is 4 and 6, right? This is x2 and y2. If we take this as x1 and y1. So now x2 is 4 minus x1 is 2 the whole square plus y2 is 6 minus 8 the whole square. So you will have 4 plus 4 and then you will get 8. The root of 8 is approximately you will get 2.83, right? Similarly, I'll go for the second data set. What is the second data set we have? We have 3, 7, F, right? This is the second data set. 3, 7. So now you have to find the distance for this. Similarly, it is the distance, right? So what is the new data point that we have already? It is 4, 6. For 4, 6, for the given sample 4, 6, you have to find the distance of this 4, 6 and all these 5 samples, right? For sample 1, what is the distance between 4, 6 and the first sample, 4, 6 and the second sample, 4, 6 and the third sample, and 4, 6 to the fourth sample, 4, 6 to the fifth sample. Then only we can be able to identify the least and least distance. So while I find this, I'll get 4 minus 3 the whole square plus 6 minus 7 the whole square. Now I'll get 1 plus 1, which is root of 2. That will be 1.41. Similarly for the third set. What is the third sample we have? 5, 5 pass. So I will take 5 and 5. 5, 5 and 4, 6 is the new sample which we need to classify. So here 4 minus 5 the whole square plus 6 minus 5 the whole square. So in this we will get the value of again 1 plus 1. So we will get root of 2 and we will get 1.41. And let me take the fourth sample 6, 6 and 4, 6. We have fourth sample is 6, 6. That's why I have taken 6, 6 and the new sample is 4, 6. So what is the distance now? 4 minus 6 the whole square plus 6 minus 6 the whole square. Now I'll get 4 plus 0, which is 2. Similarly for the fifth sample. What is the fifth sample I have? It is 7 and 5, right? I'll take 7 and 5. I have to find the distance between 7 and 5 and 4 and 6. So the distance is root of 4 minus 7 the whole square plus 6 minus 5 the whole square. Now I'll get 9 plus 1 equals root of 10. So this will give you 3.16. Right? So now I'm going to plot these values here for the first sample, right? Well, what is the first sample we have? It is 2 comma 8. For 2 comma 8 I have 2.83 as a distance. For 3 comma 7 I have 1.41. For 5 comma 5 I have 1.41, the same value, and for 6 comma 6 I have 2, and for 7 comma 5 I have 3.16. This is nothing but the sample, and this is nothing but your distance. So I have shown here the distance. Now our job is to rank this based on the distance so that I can be able to know which should be put up first and second. The least distance should be put into the first one. So in this, the least distance I'll go with 1.41, since this we have 1.41 two values, the same values for the two samples. The first occurring sample will be given the first rank according to the ascending order, and here it is 2, and this is have the next least value, and this is the next least value, and this is the next least value. Right. So I have placed the rank for all the values. So now what is the value of k? It is 3. I have to take the first top 3 rank samples. I have here 1, 2 and 3. So now I have to take the samples of 3 comma 7, 5 comma 5 and 6 comma 6. These are all the 3 nearest, more nearest or similar distance samples which we have, that helps us to identify the classifying label for the given sample. Now what is the sample that we need to classify? 4 comma 6. Now 4 comma 6, whether this comes under pass or fail, that is what we need to know. So according to our findings, we have 3 different samples which needs to check with the majority voting. Right? We'll check what is the result of this 3 samples. 3 comma 7. We'll go with 3 comma 7 and check what is the value. Here we have 3 comma 7 as a second sample. This second sample is having the result as fail. Let us write it here so that it will be easy for us to identify. This is fail. And let us go with 5 comma 5. Here we have 5 and 5. It is pass. 5 and 5 is pass, and the next value is 6 and 6. Right? Here we have 6 and 6, it is pass. So we'll go with 6 and 6 pass. So now among these 3 we have 2F, we have 1 F and 2 pass. One sample results in fail, the other 2 samples results in pass. So the majority voting is for pass value. So this value should be freezed for 4 comma 6. So 4 comma 6 will be classified as pass. So the student who is having the study hours as 4 and sleep hour as 6 will get pass mark in the exam. So this is how a KNN can classify the given sample by using the nearby neighbors majority voting, right? So initially I'll consolidate the concept. We are using an equilibrium distance. First, for the training data set, you have to find the k value. If the k value is already not being given, you have to find the k value. So k value is nothing but root of n. N is nothing but the number of total samples which is given in the training data set. According to our training data set, we have 5 data samples. That's why we have done with k equals root of 5. We have got some values. Always try to have k as odd numbers, because if it is even, it will create a tie-up problem in majority voting. So we have 2 steps. First we have to find the distance, and second step is, after finding the distance, you will be consolidating and finding the k nearest neighbors, and those k nearest, from those k nearest neighbors you will be finding the majority voting, which label is found in the majority voting, that will be freezed as the classified result for the given sample. So now I have 4 and 6 as the data sample. They have given the student with study equals 4 hours and sleep equal to 6 hours. I have taken 4 and 6. For 4 and 6, you have to find the distance for all these labels: 2, 8, 3, 7, 5, 5, 6, 6 and 7, 5. For all this, we have to find the distance with this 4, 6 using one Euclidean distance. So Euclidean distance, we have root of x2 minus x1 the whole square plus y2 minus y1 the whole square. By applying this formula, we will be finding the distance for all the samples all the samples with the new sample to be classified, that is 4, 6. After finding the distance, you have to consolidate all the distance here. So once you have written it, you have to rank it according to the distance. Whichever is having the least distance will be ranked first. Alright, so you have to rank it according to the distance which you have calculated. So once you have ranked it, you have to find the k nearest neighbors. Here the value is 3. So the top 3 rank should be taken into consideration. We have 1, 2 and 3 here, right? The first rank, second rank and third rank alone data samples will be taken into consideration. So I am going to take 3, 7, 5, 5 and 6, 6 alone. For 3, 7, as per the given data sample, we have 3, 7 as the result is fail. And next we have taken 5, 5, it is pass, 6, 6, it is pass. So we have 1 fail and 2 pass, right? So 1 fail and 2 pass. So the majority voting is pass. We have 2 pass, 1 fail, 2 wins. So the result 4, 6 will be fixed with the majority voting pass here. So this is how we can classify the given samples using k nearest neighbor. And another modification is if they have given you the k value, that's not an issue. If they haven't given the k value, you should not keep the k value very small, and also you should not keep value very large. You should always have an odd number, that to a medium k value, which is very safe for you to classify the labels. So thank you.